Introduction to D and F block elements. When we talk about D block elements, the elements which is lying in the middle of the periodic table belonging to the group that is from 3 to 12, we call it as D block elements. So, why the group from 3 to 12 are called as D block element is the elements of the group 3 to 12 in which the d orbitals are progressively filled. That is why the name given to it is D block elements. And there are three series of the elements. They are 3D series, 4D series, 5D series. So 3D series is from SC to ZN, 4D is Y to CD, and 5D is LA to HG. And the 6D series is still incomplete, but it begins with AC. So when we talk about D block elements, they are basically found in the middle section of the S and P block elements in the periodic table. And these elements have partially filled d orbital in ground state or in the excited state, and hence the name given to D block elements are transition elements. And they have been placed in the center of the periodic table. That is what we say between S block and P block elements. And iron is the most abundant and widely used transition metals. So when we talk about the electronic configuration of the transition elements, the electronic configuration of D block element is N-1, D 1 to 10, Ns 1 to 2. So they are going to have two incomplete outer shells. So here if we say N-1, that is the inner d orbital which is going to have electrons from 1 to 10. Zn, Cd, Hg, these are all the end members of first three series, and they have the general electronic configuration to be N-1, D10, Ns2. So these elements will not show the properties of the transition element to any extent. That is why it is called as non-typical transition elements. They are given a specific name, that is non-transition elements or non-typical transition elements. So this is the basic electronic configuration of the transition elements. Next, when we talk about inner transition elements, basically the inner transition elements are nothing but the F block elements, and the elements with gradually filled F orbital, they are only called as F block elements, and the elements will be constituting the F block, that is nothing but the 4f and 5f orbitals are progressively filled. That is why the name it is given as F block elements. So here we are having the two series of your inner transition elements, that is nothing but the 4f and 5f. 4f we call it as lanthanides and 5f we call it as actinides. So in detail if we see about your lanthanides, that is the 4f series, which we say it as your first transition series. So in first inner transition series, the last electron will enter in the 4f orbital. So the elements which is belonging to this series, we call it as lanthanides. The basic electronic configuration of the lanthanide is Ze 4f n plus 1, 5d0, 6s2, or we could also say it as Ze 4fn, 5d1, 6s2 with their valence shell electronic configuration to be 4f 1 to 14, 6s2. and the 15 elements from the lanthanum that we say it as your from atomic number 57 to lutetium, that is atomic number 71. We call it as lanthanides, or they are called as rare earth elements. And the most common and most stable oxidation state of lanthanide is basically +3, but some elements also exhibit the status oxidation state to be +2 and +4. Next, when we talk about the actinides, the 5F series, that is nothing but the second inner transition series. Why we call it as 5F series? Because the last electron will enter into the 5 orbital, that is 5F orbital. That is why the elements belonging to this series, the name given to it is actinides. And the elements from TH to LR, that is belonging to the series of actinides. So overall, when we count down, actinides will contain 14 elements, and they are basically a radioactive element. And when we talk about the electronic configuration, here TH stands for thorium. Thorium is 5F1, 6D1, 7S2. And for different elements, we will have the different electronic configuration. But we should remember that in 5F series, the last electron will enter in the 5F orbital, and that is why it is called as second inner transition series. Hence, it is very important to know the group or the periods which is belonging to d orbitals, or which is belonging as d block elements, and which are all the group or periods coming under f block elements. It is very important to know that in the periodic table, the elements which we are considering it as d block and the elements which we consider it as f block elements.